Hi everyone, I'm Daniel, and today I want to talk about Retrieval Augmented Generation, RAG in short. And recently we hear about RAG all the time, especially if you're coming from developing a new product today with AI. Everyone's want a RAG, and what is it? What is RAG? So if you're already familiar how RAG work, you can just skip to my next video. But if you don't really understand how things work inside RAG and what it's supposed to do and what it's doing, this is the video for you. I will try to go on the basic idea of how this system is working and what you can get out of it. Okay, so a little bit about the history. Why do we hear about it so much right now? 2021, there was a paper that was released by Patrick Lewis and Ethan Peretz. There were and some other colleague of them, and they just describe and research why RAG system could solve one of the biggest problems that we have, not biggest, but one of the problems that we have right now with LLM. Their work was actually based on a previous paper that was released by Google Labs a year before. And I believe that if you go back on the history of AI, you can find in the 90s when IBM released their smartest computer that know how to answer charades and stuff like that, you can find traces of RAG over there. And some people actually say that also in the 70s, when the window of AI just began, we also can trace some of RAG's element in solving the problems of LLM back there. So before I'm describing the problem, let's first just understand what is the definition of RAG. So enhancing LLM responses by entering real information, relevant real information into the prompt to achieve more accurate results. What do I mean? If you will go now to any chatbot, Gemini, ChatGPT, whatever, and you will ask it like a general question, what is the sun? You will probably get an answer. Why? Because those LLM was trained on a lot of information, including information that describes what is the sun, what's the temperature of the sun, where is the sun, and whatever. But if you will ask a specific question about any information that the model wasn't trained on, or information that the model was trained on but not accurate information, you will probably get either half-truth or completely wrong answer. Definitely if you ask it a question about the documents that the LLM never saw. So for instance, if you have like a legal document that you signed between yourself and your partner, if you want to ask a question about these documents, the LLM never saw this document, so it cannot help you with that. So RAG is supposed to help in these cases. Now, the first thing you can say, wait, so if the LLM never saw it before, why shouldn't I just retrain the LLM with these documents? Well, retraining is a very expensive process and usually takes a lot of time. So we don't want to do that. Then you can ask, wait, but I know that if I will introduce LLM with fact, it will give me information based on that fact. So for instance, if I will write a prompt that says, my son name is Tom, and then I will go to the next line and say, what is my son name? The LLM will respond, your son name is Tom. So I gave him fact, ask him a question, and I get a response, right? It's great and fast if you're working with small amount of information, but when you're coming for big amount of information, even if you're using Gemini and the latest model with 1 million token, and you can put like a full document into it. So your legal document, you can just feed into that model. It will take it more time and it will be more expensive. Well, not as much as training the model, but still it will take time. And we want to be efficient and fast. So we want just to take the relevant information from that document with the questions that we're asking and give it to the model. Before I will start to explain how RAG works, let's first understand how human works, because especially when trying to build system with LLM, it's more helpful to break it down to how humans think and then convert it into a system that we can work. So let's assume that we have a doctor and she have a patient, and she need to know something about the blood test, the last blood test results or something like that. Usually doctor doesn't have time to remember all of the patient and all the results and everything. So in our case, the doctor going to their assistant, whether it's an intern or a nurse or whatever, and ask him to go to the patient file, that's probably a big file, get the relevant information and answer the questions that you need, like what was the change in the blood result for the last week or something like that. Okay, so that's an easy task for humans. So the intern probably will go to the file, he will see a lot of papers inside of it, and he decide, okay, I don't need this paper because this is like, I don't know, this is not relevant to the blood result, but here is the blood test that the patient got when he arrived to the hospital, and here is the blood test that happened an hour ago and stuff like that. So he gather only the information that he need in order to answer the question of the doctor. He will collect all that in his short memory and generate an answer, right? And then go back to the doctor and say, this is the answer. So that's how human works. Now, if I will try to break it down into a software, I will need probably two components. The first one will be the one that, of course, getting the question from the doctor and then going to the files and just get the relevant file for the blood test, right? So I don't need the entire file, but I need to go over the entire file to find out what is the right information, what are the pieces of information that I need in order to get the answer to the doctor. Once I got all this information, I can just go to another system, give the question with the relevant information, and generate an answer. So by now, you probably understand what type of system I'm talking about. This answering system, it's an LLM. That's what I did before with my son name. I took a question, I got the fact that I want the answer to be generated from, and I let the LLM generate the answer for me. So that's an easy part. But what do I do with the retrieval system? And that's exactly what RAG are built for. The RAG system will allow us to get just the relevant information. But in order to get the relevant information, we need to introduce another concept, which is embedding. Okay, so I'm not going to dive too much into embedding, just the high surface of it, so for you to understand, because embedding is crucial to our solution. So embedding allowed me to take words or sentences and convert it into numeric representation of their meaning and relationship. What does that mean? Just let's take the basic thing. If I'm having like this kind of a chart that say in one corner we have how much fur we have for something, and in this corner you can see that bear, dog, teddy bear have a lot of fur on them, so they are very high on top. And the other side we can see car and motorbike on the scale of the wheels. So yeah, car have more wheels than motorbike. This is why it's a little bit to the right. Now, if I will introduce a new stuff over here, like a toy that look like a dog but have 4 wheels, then he will probably be on the right top corner because he have 4 wheels. He have more wheels than a motorbike, so it's more closer to a car. But also we got fur, so it have to be on the top because that's where we have enough fur. So that was like only 2 dimension. But I can go to much more complex model that have much more dimension. And for this example, we have a queen, we have a king, we have a woman, and we have a man. And if I will convert those words into vectors, I can see the location. And now I can also measure the distance between them. So I can see that the distance between a woman and a queen is the same distance between a man and a king. And also the distance between a woman and a man is the same distance between a queen and a king. So only by using the number, I can probably assume that if I have a queen, that she is a woman, and I want to know what's the word for a male that is the same relationship as a queen, then I will probably get a king because I can measure the distance between a queen and a woman and a man and just get where king is. So that's how everything works inside the semantic cloud. And it's actually a cloud. So I'll show you a demo how this thing looks. This is a nice demonstration of 10,000 words and in a 200 dimension. We can understand a chart of 3 dimensions, but this is 20 dimensions. So it's even hard to see it. But I can still walk around here and I can go zoom in, zoom out. And if I will take just one word, client. Okay, so what are the most closest words that we have for clients? So we have clients, we have server, clients, software, browser, user, mail, and so on. So it's gather the neighbors around this word, which also have closest meaning. So I can understand the meaning. So I don't have to look for a specific word like blood test. If I will look for blood, I will probably find there's other words that have the same meaning around the area of blood. So that will help me to get the right information back from there. So I did put the word blood here, and now I can see all the closest words that we have for it. So we have brain, tissues, liver, heart, cells, skin. If any of this is in the documents, I probably want to look at that in order to get the answer for what I need. But I was looking only on one word, but we can do also embedding for a full sentence. So we can understand where the sentence is and find the relevant neighbors or the closest neighbors around it. And that's how embedding can help us get the right information that we need from the document, right? I told you I'm not going to go deep too much into it, but I do recommend you to look for this book. This is Stephen Wolfram, and he wrote a book about what is ChatGPT doing and why does it work. This book will help you understand how LLM works. And for me, it was fascinating to read just to understand what's the foundation of LLM. And it's about embedding, about vectors, about a lot of other stuff that I don't have time to dive in. But I can assure you, once you will read it, you don't have to understand math or any deep of machine learning. It will just stay on the surface and really explain you how these magical tools work. Okay, now when we understand that we have some kind of a way to understand the meaning inside the documents and to find how it's related to the questions, we need some kind of a system that will do this retrieval, right? So we need some kind of a database that will help us store those meanings and find those neighbors. And for that, we have vector database, which it's like any other database that we know, but his specialty is to store vectors and help you find semantic meaning between them, the connection between them, or how far away they are from each other. So if we have vector database, what we should do is take the entire documents of the patient, prepare it, and in preparation, sometimes there's images there. How do we deal with the images? Sometimes there's the table there. How do we deal with the table? But we need to prepare the image into a content that we can use and store it into the vector database. And before we store it into the vector database, we need also to split it apart. Why do we do the splitting? Think about that. I can take a document of 100 pages. If I will just do a 100 pages embedding, I will get one vector that will mean absolutely nothing. Because usually the meaning is in small chunks inside text. So I want to get into sentences, paragraphs, something that is not too big, but can still contain meaning inside of it. And those bubble of meaning, those chunks of meaning, this is the type of information that I want to store into the vector database. So that's how we're doing the pre-processing. We're getting all the information, converted it into something that we can work on and embed it, and then slice it into chunks, and then take the chunks using the embedding system and store it into the vector database. And now, if I want to get something out of the vector database, I just need to take any questions I want, using the same embedding system to get the vector out of it, sending it to the vector database and said, okay, send me back all the chunks of data, all the chunks of text that are close to the input that I just gave you, which is the question. Okay, so I'm taking a question, sending it to vector database and getting all the information from the documents that are close meaningly to that type of information. And that's the retrieval system. So going back to our diagram, we have a question, we're changing it to embedding, we're sending it to the DB, we're getting back chunk of information. Now we can go back to the LLM, and with the same example that I showed before, we're just giving the question, giving the information, and asking the LLM to generate an answer based only on the information that we got from the vector database. And that is the basic foundation of RAGs. So if it sounds complicated, let me show you how easy it is to write it on a code. I'm using a Python notebook that's running on my computer just to show you how easy it is to write it down. I'm starting with installing all the libraries that I need, and I'm going to use LangChain. LangChain is a open source platform that help us build really quick solution that using LLMs. And I'm actually loading all the function and classes that I will need to run it. And here I'm defining a new LLM that is based on Chat Google Generative AI. I'm taking the latest model of Gemini 1.5 Pro, and I'm setting the temperature to 0. Temperature 0 is usually says how randomized it's going to create the answer, which means how creatively the answer is going to be. And in this case, we don't want a lot of creation. We just want him to use the information that we're providing from the vector database and to answer as accurate as it can the answer. So I'm setting it to 0. And then I'm asking a question. What is the innovation drama? And let's run it. And you can see that after 8 seconds, almost 9 seconds, it gave me an answer that it doesn't really recognize the term the innovator's drama. He doesn't know what it means, but he can guess and just give me some kind of speculation what it could be. And the reason that it doesn't understand what is the innovation drama is because this term was coined by a friend of mine, Uri Gavriel. About a decade ago, only recently he published a book about it. And you can see that I have the book over here in a PDF. And over here, Uri explained exactly what is the method and how to use it. But Gemini was never trained on that specific book. So it doesn't know what the innovator drama is. Therefore, RAG system would be perfect here. So first of all, I need to take the document, the PDF, which I have stored local on my computer, and I need to convert it into text. And I'm using a library that already integrated into LangChain to do that. And in the end of it, I will get, let me just show you, I will get all the book inside here as a text with all the separation, new lines and everything. It's a huge one, so I'm not going to go over it, but that is the entire book. But as we say, entire book doesn't have a lot of meaning. We need to break it down. We need to slice it. So I'm using a different library just to slice it and to chunk it. And I chose to do it by size of the characters. But just cutting by characters number won't be good enough, because if it will break it in the middle of the sentence, I might lose the meaning of the sentence. And then the next chunk will have some kind of the middle of the sentence without even understand what's going on. So this specific function will allow me not to break it only by the number of characters, but also look when the line is end or a paragraph in end, and only do it and only chunk it over there. So that's a little bit of help. There are many different methods how to chunk the information. I'm not going to get into that right now, but after I run it, I got 477 chunks of information. And if you just look at one of them, we can see that this is actually the beginning, I believe, of some kind of a sentence, and then he's giving the rest of the information. And we have 477 one of that. So now we need to store them into a vector database, and here I'm using Chroma, which is an open source vector database that I can run locally on my machine, and that's what I did. So I just gave him all the information and tell him, okay, just put it in your database, and when I want to retrieve them, I will use you again. And now I'm just defining the RAG. So first of all, I have to define the retrieval. As we said, that's the vector database. It's very easy. It's very easy when you're using LangChain. And then I defined a prompt. So I already took a predefined prompt for RAGs, but let me just print it out over here so we can see exactly what's going on. We don't care about all that. We do care about this template. So you're an assistant for question answering task and blah, blah, blah. You always have to use, if you don't know the answer, say that you don't know the answer. And in the end, we're giving the questions as a parameter and also the content. And this is important because later on, when I'm using the prompt, I have to give them the question and the contents. So let's go back into here. I also created a function here that just know how to take the text from what we're retrieving back from the vector database, because when we're retrieving, we're also getting some kind of a metadata that we don't really need for this example. So I'm just cleaning everything up, so the LLM will just get the chunks of text and nothing else. And then I'm creating a chain. This is the LangChain option. So I'm taking the content, which is using the retrieval and the function that we use, and I'm taking the question and I'm just reformatting it to make sure that I'm just getting it as a clean string into the question part. I'm taking all of that and I'm putting it inside the prompt that we just saw. The prompt I'm sending into the LLM, and then the answer from the LLM I'm just sending into a parser that will just filter it out, because usually when you're getting answer from LLMs, you're getting a lot of information, including the generated text that you ask for. And I just want to present the text. So now let's take this chain and invoke it with the same question. And after 3 seconds, we got an answer. Let's hear the answer.
The Innovator's Drama is a book about how drama is an integral element of changes, transformations, and innovations. It argues that innovators need to embrace drama in order to push through pushbacks and achieve progress and prosperity. The book offers a method for streamlining creativity at scale by understanding and managing the dramatic aspects of innovation.
So yeah, he definitely knows the book right now, and he knew how to generate an answer that is very correct and very accurate for what I needed. And that's basically what's RAG doing. So if you have any more questions, use the comment. Please like and subscribe if you learned something new today, and stay tuned for my next video. See you soon.